Hello everyone, in this video we are going to talk about the CFG simplification. CFG, we know the context-free grammar, and how can we simplify the context-free grammar? What do you mean by simplification, and what will be the end result be after we simplify the grammar? Will it be representing the same language, or will we be able to generate the same language after simplification? That's what we are going to talk about, and the various steps involved in the simplification will also be discussed. Okay, and after simplification we'll have a grammar called as reduced grammar, meaning we are going to reduce the grammar by removing some unnecessary things from this given CFG. Okay, what do you mean by that? First one is we are going to remove the useless symbols from the grammar. We know the grammar in general will be having four components: variables, terminals, productions, and the start variable as usual. Okay, and we are going to remove some useless symbols. When can we say a symbol is useless, and how can we remove them from the grammar? That will be step number 1 in the simplification of a context-free grammar. Then we are going to eliminate the epsilon productions or lambda production or nullable variables. Okay, the reduced grammar will not have any epsilon production, but will it be generated in the same language even if you remove the epsilon production? Yes, it will be, but how can it happen? That's what will be step 2. That's what will be discussed as part of step 2 in the CFG simplification. And part number 3 or step number 3 in CFG simplification is the removal of unit production. What do you mean by unit production? How they can be removed from the grammar. Okay, after completing all these 3 steps, we will have something called as a reduced grammar or a simplified context-free grammar. Okay, and in the examinations or in the competitive examinations like GATE and all, you may come across this question also. Okay, and what will happen if you remove epsilon productions? What will happen if you remove unit production, or identify the unit productions, or identify the nullable variables, or identify the useless symbols of this grammar? All those sort of questions are expected in the competitive examinations also. Okay, let's go into the discussion about how CFG can be simplified with the discussion about step 1, the removal of useless symbols. Here we go. Let's try removing the useless symbols from the given CFG. For that, we should understand why are we calling it as, or why do we call it as useless. Okay, and here are the definition. Here are the properties of useless symbols. A symbol can be useless if it does not appear on the right hand side of the production rule and does not take part in the derivation of any string. Seems very logical, right? If the symbol does not take part in the derivation of any string, what is the need for that in the grammar? Okay, that is why we call it as useless. Those sort of symbols are termed as useless, and we need not have them in the grammar at all. It is not going to affect the strings which are going to be generated, because they are not going to take part in the derivation of any strings at all. Alright, so if it wants to take part in the derivation, it should be appearing on the right hand side of any production, right? Then only from the start variable we will be going into that production. So if it is appearing on the right hand side of the production, then we can make use of it, or it will be taking part in the derivation of any string. But if it is not, then there is no point in having those symbols in the grammar. Okay, so those symbols are known as useless symbols. Similarly, a variable can be useless if it does not take part in the derivation of any string. So here it talks about a symbol in general. Here it is specific about variable, meaning variables can be useless, terminals can also be useless if it is not appearing. For example, say the terminal set has 0, 1, 2, okay, and the productions are in the productions 0, 1, 2 are not at all appearing, or 1 or 2 are not at all appearing on the right hand side, then they need not be there in the grammar at all, right? So the symbols can be useless, variables can also be useless. Okay, and those variables are called as useless variables. We are going to remove them from the grammar because they are useless. They are not going to be useful in generating any strings of that language. Okay, and consider this example. Grammar, we have got 7 productions, 3 for T, 1 production for the variable A, 2 production for the variable B, and 1 for the variable C. Okay, if you look at all those, now all these all these productions, the variable C will never occur in the derivation of any string. Okay, so if you look at this sorry, so this is the start, this is going to be the start variable. Okay, we are going to start the derivation process from the start variable T as usual. Okay, we can replace T with either AAB or ABA or AAT. All right, and if you are using this, then A will be replaced by some other product, some of its productions, or one of its production. B will be replaced by its production. But in that course, we will never come across the variable on the right, variable C on the right hand side. Okay, so A also does not have C on the right hand side. B also doesn't have C on the right hand side. T also doesn't have C on the right hand side, which means C will never be useful in the derivation. So we can simply remove that from the grammar, term it as useless production. Okay, so that's why we have the statement written like this: the variable C will never occur in the derivation of any string. So the production C gives AD is useless, we can eliminate it. And the other productions are written in such a way that the variable C can never reached from the starting variable T. That's what. So from T we cannot reach the variable C by any means. That's why we call C as useless straight away, right? Then comes production A. You might be wondering why we have A appearing here. We can reach A from T. Yes, it is reachable, but if you encounter this variable at any point, okay, for example, if you use this production ABA to replace this T, and we have got only one variable A, it has only one production AA, fine. A, this A can be replaced with A again. It keeps on generating uppercase A in each and every step. There won't be any end for this uppercase A, the variable A. It will be appearing in all the remaining steps also. Okay, and now let's read this statement. Production A gives A is also useless because there is no way to terminate it. That is an important point to note. Okay, if here C was reachable, that's fine, we were able to understand. But even though A was reachable, it appears on the right hand side of the productions. It has its own production as well, but we do not have any production that will terminate that A. Okay, so please remember, the valid strings of the language will always have only the terminals. You should keep this in mind all the time. Okay, the valid strings of the language will always have only the terminals or the product or the null T star union lambda. Okay, that's what will be there in the valid strings of any language. Okay, so if you use this production, we will have this uppercase A all the time. We won't be having anything that will terminate the appearance of A. Okay, so A will also be useless, a critical and important property. Okay, meaning it will not take part sorry, in the generation of any valid string. Okay, it will be able to replace this uppercase A, but it will not stop. It will keep on generating uppercase A, at least one A in each and every step. Fine, it will never terminate. Then it can never produce a string. Okay, here this string is talking about the valid string because it can have only terminals or the null string. Fine, but is it enough for us to remove only this? No, we should remove A, and if you remove A, this production A gives AA, then there is no point in having this also. Alright, because we have identified A as useless, this production will also go away from the grammar. So we'll first find all the variables which never lead to a terminal string, such as the variable a, then we will remove all the production in which the variable a occurs. So wherever we find the uppercase a, that will also be removed. So this will also be removed from the grammar. This production will not be there. This production will also not be there in the grammar after we remove the useless symbols from the grammar. Okay, and remember we have done only the first step, and this is the first step in the simplification of context-free grammar. For your information, removing the useless symbols. If it never appears on the right hand side of any production, remove those symbols. Sorry. If it does not take part in the generation of any valid strings, then also it can be removed. There may be some cases, like for example, if for B, okay, if we have something like this, and no, B is appearing, but B doesn't have any production at all. So it is a variable, then there should be a way in which we should be able to replace it. So even if we do not have sorry, if we do not have any production for any variable, then also the variable should be termed as useless. It should be removed from the grammar. Okay, so you should think logically, and most of the time it will be very straightforward, but sometimes it will be a trickier one like this also. Okay, even though it has a production, but it will never terminate to produce any valid string, so it should be termed as useless symbol. Step number 1 completed. Let's talk about the elimination of epsilon production, and let me remind you, or let me tell you, this is one of the complex steps that you will have in the simplification of context-free grammar, because we often get confused, even if we haven't got confused already. Fine. What is elimination of epsilon production? So looks very innocent as usual. Epsilon production. Alright. The productions of type S gives epsilon are called epsilon production. Okay. Very cute and very nice definition. And these type of productions can only be removed from those grammars that do not generate lambda or epsilon. Okay. And S gives lambda, okay fine, S gives epsilon are called epsilon production, but it is not that you can always remove epsilon production, but if the language itself has epsilon as a valid string, then S gives epsilon should be there. Alright, but if you are able to identify some other nullable variables, what is nullable variable? Something like this. B, C, and B gives lambda, C gives lambda, then A can also become nullable, right? If we substitute lambda for this A. So these are all called nullable variables. Non-terminals are nothing but variables, right? Non-terminals are called as variables, right? First we need to find out all nullable variables which derives epsilon. Okay, it's not necessary to have the epsilon production straight away, but if it is able to derive epsilon, then it is called as nullable. Okay, that's why I call it as the complex step in the reduction of grammar or simplification of CFG. And for each production A gives A, construct all production A gives S, where X is obtained from A by removing one or more non-terminal from step 1. I know you haven't got anything from this step 2, you will be able to understand with the example. And after doing this, we need to combine the result of step 2 to form the grammar without the nullable variables, right? Nullable production, I mean epsilon production. Here we go. And assume that we have these 5 productions in our grammar. S gives x, y, x, x gives 0x or epsilon, y gives 1y or epsilon. Alright. Excuse me. Now we are going to delete the rule x gives epsilon and y gives epsilon, because they are epsilon productions. We need to eliminate epsilon production. We are not removing nullable variables. Please remember, in the previous step we removed useless productions. Here we are not removing nullable variables, we are removing null productions or epsilon productions alone. But how? That's what we are going to see. And to preserve the meaning of the CFG, we are actually placing epsilon at the right hand side wherever x and y are appearing, right? And let's go one by one. In this production, S gives x, y, x. First, let's consider this production alone. X gives epsilon. If x gives epsilon, this can also be epsilon, this can also be epsilon. Okay, if you substitute epsilon for this x, we will have yx as the production. If you substitute epsilon for this x, we will have xy as the production, as we have got here. Okay, if the first x at the right hand side is epsilon, we will have x gives yx. If the last x on the right hand side is epsilon, then we will have xy. If y is equal to epsilon, then we will have xx. Okay, if y and x are epsilon, we will have x gives x. Okay, and if both x are substituted with epsilon, then we will have s gives y. Okay, now you might be wondering what will happen if x, y, both x's and y are substituted with epsilon. It will generate s gives epsilon, which is not our aim. All right. Sorry. Fine. Now we had only one production for the starting variable s. S gives x, y, x, but after removing the epsilon production, we have got 5 productions for the variable s, right? So yx, xy, xx, x and y, all those are going to be productions of s, just because we are not going to have x gives epsilon or y gives epsilon in our grammar. Okay, fine. That's about this single production alone. Okay, we have substituted epsilon for x and epsilon for y alternatively. We tried all possible combinations and we end up with this one. Fine. Let's talk about x gives 0x. Okay, and if it is epsilon, it will be 0 only. But we have got alternate production also, s gives 0x. Now most of the time what we may tend to write is, we will have only this production for after trying to remove the epsilon production, we may have only this production, s gives lambda. Okay, but we should have this production also. Why? Because this production can generate more number of zeros also, right? Zero x. So it has the ability to generate more number of zeros followed by a single x, right? So we cannot stop that production from being there in the grammar. Okay, all that we are trying to do is to eliminate epsilon production without satisfying the meaning of the grammar, without sacrificing the language being generated by the grammar. Okay, so this production will be there. So instead of this x, we are substituting epsilon, so that will give us 0. So this will go away. Okay, if you substitute epsilon for x, we will have 0 also as an alternate option. Okay, so please don't remove 0x blindly. All right, it should be there. Same is the case with these productions also. So y is a nullable variable, it has an epsilon production, right? So in 1y, if you substitute epsilon for y, we will have 1. Okay, so 1y is also going to remain because it has the ability to generate any number of 1s followed by a single y, and then we can replace that with 1. Okay, so the point is to remove epsilon production alone, not all the productions of x or y. All right, so for y we will have the production as 1y followed by 1. Okay, for x it will be 0x followed by 0 instead of this epsilon. For y, instead of this epsilon, we will have 1 as the production. Okay, so now if you combine all these productions from step 2, this is what step 2 is. Okay, after identifying the nullable variables, we have substituted the epsilon for all possible options. I mean, we tried with alternate options also, right? Now if we combine them together, we will get a grammar like this. This will be the grammar without epsilon production. Okay, without epsilon production, not the reduced one. Let me remind you, this is one of the steps. This step 2. First one was removal of useless symbols. This one, removal of epsilon productions or lambda productions from a CFG. Okay, Then comes this step 3, removing unit production. I would say it's fairly straightforward than the first two, one of the simplest or the simplest step that you have in the simplification of CFG. Okay, unit productions are productions in which one non-terminal gives another non-terminal. What is that? What do you mean by non-terminal? A variable, say a variable gives another variable. This is called as unit production. Okay, gives another, so without anything else. Okay, on the left hand side we should have only one variable, obviously, because it is a CFG, and if we have only one symbol, only one variable like this on the right hand side, then it is called as unit production. Okay, meaning whatever the production of B will be the production of A indirectly. Okay, if one non-terminal gives another non-terminal, then it is unit production. How are we going to eliminate that? By substituting. Okay, to remove x gives y, add production x gives A to the grammar if y gives A is a production. Okay, to replace this variable, we are going to make use of the production of B, the right hand side of B instead of this single B. Okay, and if x gives y and y gives A is a production, so to replace this y, we are going to substitute this variable like this, x gives A, that is the meaning. Okay, and x gives y will be removed from the grammar because we have already substituted. So that is going to be the mean, and this step should be repeated for all the productions also, all the unit productions like this. And if y gives A or AB are two productions, then x gives A and AB will be the two productions. Alright, this is how the unit production will be eliminated from the grammar. Why should we eliminate the unit production? Because it doesn't make sense. Alright, if A gives B and B gives some variables, instead of having this production, we can directly have the productions of that variable straight away. Okay, it's like doing an extra step. Instead of that, we can directly use the productions of this variable straight away. Here is an example. Now consider these productions. S gives 0A, 1B, C are the productions of S. A gives 0A, 0, 0, B gives 1A, 1R, C gives 0, 1 are the productions. Okay. Now if you try, we have S gives C as a unit production, B gives A also as unit production. Sorry. Okay. Now what can we do here? Instead of using this as the unit, instead of having this unit production, we can use the right hand side of the production here. Okay, so the production of S will be 0A, 1B, there won't be any changes there. Instead of this variable C, we are going to make use of the right hand side of the production, 0, 1. Okay, for A there won't be any changes. We have A gives 0S, 0, 0, no unit productions are there. For B we have one unit production, B gives A. So one remain as it is. For instead of this A, we will be using these two productions, 0F and 0, 0. Okay, and we'll be having the unit production, so the production like productions like S gives 0A, 1B. Instead of the C, there will be 0, 1. A gives 0S or 0, 0. B gives 1 A. So instead of A, we have these two productions on the right hand side of B. Then comes C gives 0, 1. And you might be wondering, what about C? It is not appearing on the right hand side of any production. Yes, it is an useless variable. We need to remove that variable. But this is just, this slide is just explaining how the unit production can be eliminated. Okay, so we need to follow useless production elimination, lambda production elimination, then you should come for the unit production elimination. But this slide talks exclusively about how the unit productions can be eliminated or not. Okay, so if you are given at the grammar, then you should be following all these 3 steps so that you will be able to find the reduced grammar called simplified context free grammar. First one was removal of useless symbol. When can we say a symbol is useless? If it is not appearing on the right hand side of any production, or if it is not taking part in the generation of or derivation of any string of that grammar, then it is useless. You can simply remove the variable from the grammar and the associated productions also. Okay, so that's what we did. C was not at all appearing on the right hand side. A was not at all terminating. So after removing this A gives AA, we removed this also, ABA also, because there is no need for that. Alright, that is what useless symbol elimination. And then we eliminated epsilon production, that's by substituting for the combination. Okay, after identifying the nullable variables, we substituted lambda for variable combination of positions for the different positions. Then we found the productions without lambda production. Okay, and as I said, please be extra careful in this area. Okay, so while removing x gives epsilon, you should not remove 0x straight away. All right, so because of these reasons. All right, so then comes unit production elimination, the straightforward elimination, and instead of having a production like this, we can simply use the production of this variable on the right hand side straight away, so that we can reduce the derivation step while deriving the strings. All right, so that's all about this presentation. Hope you have identified the simplification of context free grammar, so that we can find the reduced grammar. We'll talk about the normal forms of context free grammars in the next video. So thanks for listening.